We have a unit circle, which we're going to go into in a second, but we start off with trigonometry of this triangle here. If I have 2, 2, 2 as in the side length, therefore in the degrees in each corner, Manny, what are they?
60.
They're all 60s. Okay, let's just say I was mucking around and I kind of wanted to cut that in half. We're going to have, therefore, 60 turns to 30 degrees. And if I then take away this, what else can I put on here? Or what else needs to change, Gabe?
Sorry, the length of the bottom.
The length of the bottom is now
1.
1. How do I find out what my height of my triangle is? Okay,
Wait, what? Height.
this side here. Pythagoras theorem. Back to year 9. Okay, so therefore, what's Pythagoras again?
A squared plus b squared equals c squared.
Okay, good. What's my C in this case, Maya? It's a 2. And my A's and B's, let's say this is our X. Backtrack. 4, 1 plus X squared. What's on the other side now? If 1 moves over, now the 3, X squared. Once again, X is root 3. So now we've got a root 3 here. Everyone with me so far? So once we've done with that, I'm now going to ask you some questions. I'm going to ask you what that is. I'm going to ask you what this is. And I'm going to ask you what this is. Sine 60 degrees. Emily, what is the ratio of sine? Over h. So root 3 on 2. Okay. Annie, cosine 60 is? So Gatoa?
A over h.
A over h. And A is what? What's A in here? From the 60?
Square root of 3.
Square root of 3.
Oh, no, 1.
1 over
2.
2. Say 10 60. What's 10? What letter over what letter? In regards to O over A. What's my opposite from the 60 degree in my triangle?
30.
Sorry. What's the opposite? From an angle, opposite is a root 3.
Of course, square root of 3.
Yeah. And what's my adjacent?
1.
It's a 1. Okay. So we could just be left with that. What are we saying here? If I had 60 degree, if I place that triangle in here, in a way, and I said 60 degrees in here, and if I know that my x and y is my cosine theta, sine theta, but I now know an angle of 60 degrees, so therefore it's cosine 60, sine 60. Therefore, what is the final coordinate answer of a 60 degree angle in a unit circle? What is it? What did we just figure out? Cosine 60 is?
Root on 3
Yep. Root 3 and 1. Are you sure? Cosine 60?
But
1 over 2.
1 on 2. Yep. Sine 60 is? We just figured it out, root 3 on 2. Think about it. We're saying that this, the coordinate is that at 60 degrees. This is a unit circle. This is a triangle with hypotenuse of 2. Can you see why we've had to halve our 1 in root 3? Yeah. What we really did, we started off with our triangle. We're trying to fit it into here. But this only goes up to 1. Our triangle goes up way to 2. That's why we've got to halve these to get back onto the unit circle. Half and root 3 on 2. Okay. Now, we're going to do this now. 30 degrees, 30 degrees, 30 degrees. Means these are all going to change. Sine 30 degrees, Perry. It's a 1 on 2. Okay, sine 30 degrees, Jesse. Looking at the 30 degrees. Root 3 on 2. Good. I know the double maths is up. Zach?
1 on root.
It's a 1 on root 3. Good. Okay. What does that mean here? If this now changes, I now sink down to 30 degrees, which is here. That's 30 degrees. Therefore, my new coordinates, if I just read them off, is root 3 on 2 and half. Right in there. Can you sort of imagine if I flip this into here, that same triangle appears? But it's just been flipped. So this is the root 3 on 2 now. Okay. All right. A few more to go. You need to, in the exam or in the SAC where it's no calculator, you need to memorize this off by heart, that to help you out with exact values. Because when they give you questions with 30s and 60s, you know that they're referring to this triangle here. And if you know the triangle, you can work out any 30s or 60s. So,
Is it test next one?
yes, it
And
is.
you just said there's no calculator.
No, I'm just saying if.
Okay.
Yeah.
Can we get the calculator for
You
next
will.
week?
You will. Okay. All right. Let's have a go at these. I want you to figure out what sine 150 is and cosine 690 with just this triangle. And the help of your unit circle. So, let's look carefully. 150. Which quadrant is that? Quadrant 2. How far away is it from 180? 30. It's popped up. The 30's popped up. Okay? So what's my answer? $150 is the same as our reference of 180. Windscreen wiper back by 30. Okay. Do the signs change when we're comparing it to home base?
No.
It doesn't.
Still above.
It's still above. So this is 30. This is sine 30. So it's the same as our home base, sine 30. Okay. And what's sine 30 using your triangle? 1, 2. Cosine 690. Think about it. In degrees, 1 full circle is 360. Quadrant 4. Minus, we're going back. 30 again. 30 away from 720, 2 pi. Or 4 pi, my bad, 4 pi. Okay. So we rewrite 690 as a 720 minus 30. And if we refer back to home base, does cosine change down here?
No.
No. So cosine is just a positive. Using our triangle, cosine 30, reading off from 30, and adjacent over hypotenuse is a root 3 on 2. Okay. We've got a few more to go. Good. You guys are getting it. I'm happy. A little bit more tricky. Still doable. I've got 2 here. What's my reference angle if it's pi on 6? Which quadrant? If this is pi and this is 0.
Oh, 2.
It's 2. Can anyone explain why Tim said 2? 5 pi on 6.
Just less.
It's just less than pi. 6 pi's on 6. We go back 1 pi on 6. Okay. So our reference is a pi. Take away pi on 6. So it's a version of our home base of pi on 6. Does it change signs though? Cosine. Yes or no? Okay. It is positive x, negative x if we're looking at cosine. Okay. So this is a negative cosine. Pi on 6. Over here, 60 degrees. And if I rewrote that as pi, 60 degrees is pi on 6. No, pi on? Good, thank you, Zach. Pi on 3. What's pi? What's 30? Pi on? 6. So you have to be ready to answer this triangle questions, whether it's in degrees or radian. Negative cosine pi on 6. I go from my pi on 6, adjacent of a hypotenuse, negative root 3 on 2. Sine 13 pi on 6. What's my reference angle, Emily? Yeah, am I going to read it off from 0 or from pi? From 0, good. Which is 0 is the same as? 2 pi. Can everyone see how this is the same? You got that? You got to it takes a bit of practice. And we know that 12 on 6 is 2 pi plus pi on 6. So we're after a version of sine pi on 6. We want to get back to that. Is it the same? Okay, so yeah, so sine pi on 6, I just said, not quite. Sine pi on 6.
Oh, it was like, oh,
Okay. Okay. Remember, 2 pi is just spinning its wheels? So we're just really back into here. Went to pi, 2 pi, and then a little bit more. We're back at home base. Home base is home base. Sine pi on 6. Pi on 6. Opposite hypotenuse. As Tim said, it's half. Okay, I might skip. We'll just do the last two.
Yeah.
5 more minutes, guys. 5 more minutes. We're going to do a 10.
It's just too long.
Too much today?
Yeah. I'm not so close to getting it, but it's so much to take at once.
It is, I know. Okay, last two. 23 pi on 6. What is a good reference point for 23 pi on 6? Where should I read it from?
8, 5, 6, 5, 5, 6.
Okay. Say it again, Tim.
18 pi over 6 plus 5 pi over 6.
Good. You're right, but we can go that way, but I want to get a bit closer.
3 pi.
I want to closer.
Oh.
Okay. Did anyone have 24 pi and 6 in your head? Jesse? Okay. Good on you, Jesse. Because if you look carefully, we see the clue, the denominator is the clue. So the second term we know is going to be over 6. So therefore, this bit here is a 24 divided by 6. And what was that, Jesse? It's a 4 pi. Good stuff. And we know with even pies, there are repeats of 2 pi's. 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. Just spinning. 4 pi is the same as a negative 5 on 6. Well, let's take the long way. I'm just going to take the long way. You don't have to do this. I'm just being explicit here. You can go from here to here, straight to here, if it's quite clear in your head. 4 pi's are really 2 pi's. 2 pi's are really zeros. We're just going down. We're just going down here. Okay. So therefore, tan negative pi on 6. What degrees? 30. What's the opposite? 1 on root 3. Positive or negative? Okay. I should have written this down here. That's right. This is a symmetry I wiped it off. But through that symmetry diagram, tan negative is a negative tan. Through the symmetry. Last one. Okay. Eleven pi on 4. 11 pi on 4. I'm going to wipe this off. Two more minutes.
12 pi on 4 minus 1.
Okay, look carefully. 11 pi on 4, we deal with quarters. Okay? You do, Tim. Yes, you do. Okay, don't worry. Over time, they'll be fine. Okay. If this is pi on 2, what's this? Pi on 4. If that's a half, it's a quarter of a half. Okay? So now we've got pi's on 4s happening everywhere now. Well, let's just do these two. All right, look carefully. 11 pi 4, 3 pi. So, Tim has said we're looking at 3 pi, I think.
3 pi? No, like the from there. Between the pi.
In between here. Yeah, we won't go there.
But it'd just be 3 pi minus.
It's a 3 pi. Yeah, but I'll just take one more mini step in between, game. Okay, 11 pi and 4 is the same as 12, take away 1. Are we good with that? But we know 12 pi and 4, as I've been hearing, is a 3 pi. Take away pi and 4, which is the same as a pi minus pi on 4. Okay? Which is the same as, if this is sine over here and we're in this quadrant, does sine change between home base and the second node? So therefore, it's just sine pi on 4. Now, this is what happens. If I start here and I go across 1, and then I go up to 1, I create a triangle. The base and the height are both 1. What are we going to use to get a hypotenuse? Okay. 1 squared plus 1 squared equals our x. What's our final answer? It's not 1.
2.
It's root 2.
Wait.
Why?
Oh, yeah.
Good question. Because it works. Yeah. Why are we doing 1 and 1? Okay, think about it right now. If that's 1 and 1, and this is, let's, why are we using this triangle?
Units is 1.
It's, not quite.
What's this chapter? It goes to actions.
Okay,
Oh, because the gradient is
yes.
just well there.
Good, okay.
Because 1 on 1 is just 1.
So just tell us.
I'm waiting for the discussion second.
Yeah. rate is just 1 on 1, which
Okay.
is 45 degrees.
Okay, good. So if I go in a 45 degree out, if I look carefully, if I go 45 degrees out, that's 45 now. I'm equally going out to this one. This and this are going to be the same length, whatever that is. Are we good? Which means it's a 1-to-1 ratio. If you actually constructed a triangle and measured 1 and then up 1 and then did that and you got your protractor out, it'll be 45 degrees. We can now find the hypotenuse through Pythagoras of root 2. Okay? Therefore, if I'm after sine pi and 4, which are these now, what's 180 divided by 4? It's 45. Okay? I can go to any angle from here. Sine pi and 4 is an opposite of a hypotenuse, which is a 1 on root 2. Okay, that's one version. But you can also have another version. What technique am I doing here? What's it called? Rationalizing the denominator. Remember, I can do that because that's 1. I haven't changed the value. So really, we can also have root 2 root 2 on 2.
Yeah,
Root 2 on 2. Sorry, I missed it. Because 2 root 2s end up with a 2. I almost lost it. Guys, I know that's a lot.